Welcome. Good morning, everyone, and welcome. My name is Yashasvi Suryavamshi, and I'm a field application engineer for VLSI here at Trident Techlabs. Today's session is called Root Cause to Resolution Debug with Confidence. And in this session, I will be giving you a brief look on how Questa OneSim helps you to do exactly that. That is, by finding bugs faster, trace them to root cause, and close verification with confidence. So before we start, let me ask with the quick question. How many of you have started a waveform, how many started working on a waveform and stare at it past your working hours where the output bus just shows X and has no idea where it's coming from? So before the solution that we see, let's understand the problem. The data here is quite clear, and this data is taken from the Wilson Research Group. And here, the design complexity continues to grow, and we are seeing a clear decline in the ASIC first silicon success. Historically, about 30% of ASIC projects achieved success on the first spin. But as shown here, that number has steadily dropped, with only 24% of projects reaching the first silicon success in 2022, and almost 36% finishing on schedule. And even the FPGA side is also not doing much better. Only 16% of the project managed to avoid a non-trivial bug escape into the and yeah, only 16% of the project manages to avoid this non-trivial bug escapes into production, and 30% of the projects finish it on time. Adding to the worsening trends of the project schedule and the first time silicon success, there is a rising need for more engineers that can work on the next generation of projects. To tackle the present and future challenges effectively, we need verification solutions that enhances efficiency by automating the repetitive parts of verification, like boosting productivity by unifying tool chains so that the engineers not switch between the tools and spend their time in debugging, and improving the cost effectiveness by lowering the simulation runs. And this is where Questa One comes into the picture. Questa One is the Siemens' answer to the modern verification challenge. Questa One improves the total user productivity up to 5 times, and that is delivered through faster engines, faster engineers, and fewer workloads. Faster engines means like raw simulation throughput, and faster engineers mean a smarter debug environment, and fewer workload means AI-driven automation that handles repetitive coverage closure to work. And all these three together gives you that 5 times productivity. So Questa One is actually a family, and it has four main product lines in it, which are tightly integrated together. Questa OneSim. Speaking about Questa OneSim, it provides all the dynamic simulation capabilities, and this would be the focus of our session today. And we have Questa One Verification IQ, which is the verification management solution. And we have Questa One SFV, which encapsulates the static and formal verification products. And we have Questa One Every VIP, which is the verification IP solution for protocol and chiplet verification. And if you're interested to know more about these product lines, we have the next sessions lined up for these, or we can even have a session plan based on your interest tailored especially for you. So now today we go deep on Questa OneSim. So Questa OneSim is a simulation solution engine that is that whose purpose is built to meet the performance and the productivity demands of today's verification team. And within it, we have our three pillars, which are the faster engines, faster engineers, and fewer workloads. So starting with faster engines, it is powered by a new simulation core and advanced parallelism technologies. These engines bring higher capacity and faster turnaround time across both RTL and gate level designs. We enable the faster engineers by providing next generation debug and profiling tools that help engineers pinpoint and resolve issues quickly and improving the overall throughput. And we drive fewer workloads by using coverage acceleration, smart compile, and DFT acceleration, all aimed at reducing redundant work and shortening the verification cycles. Together, these capabilities seem like they're working seamlessly across the industry standards and methodologies and across all the platforms and environments as you see here. Before the specific debug feature with Questa OneSim, we have to know that we can debug it both interactively during the simulation and offline even after work. That is in both live and post simulation modes. And in both the modes, you will have access to nearly the same rich set of debug features. So talking about the live simulation mode. So the live simulation mode is when the simulation is running, you have full access or like full interactive access. So you can set the breakpoints, you can inspect signals, you can add waves on the fly, run the tickle commands, and you will be actually debugging in real time. And when you're talking about post simulation mode, it is mostly like after the run, and all of the data is saved to a UCDB, and the waveform database. All of the data will be saved in form of a UCDB and the waveform database. So you can load these into your visualizer offline and replay the entire simulation. You can even navigate time. You can inspect every signal, trace the drivers, all without rerunning your entire design. So now talking about one of the trickiest part of simulation debug, which is dealing with the X issues. So those unknown signal values which spread when something isn't initialized or power up. So X signals are something like you don't even know like sometimes how it is initialized or powered up. They just don't appear. They leak through your design over time. And by the time you actually notice them, like hundreds of flip-flops in your design or any other components in your design may already be corrupted. And that is where you will be doing your X debug. This is one of the features that like once you've used it, you will wonder like how to ever debug without it. And so instead of like chasing the X's after they've spread, it actually lets you to see them as they appear over time. And this feature is actually seen inside the visualizer's GUI. And here you can get a heat map of your design where each block is colored from green to red. And as the simulation plays, you can scroll through time and watch how those X's move and grow. So here you can see on your screen, you can see the blocks in red, which will show you the X debug heat map of your design. And you can literally pinpoint the moment where an X leaks and not just where it just ends up. So this tool also creates an interest points actually, which automatically whenever X activity spikes, like for example, like when X suddenly crosses into another clock domain or it hits a key register, you can like jump straight to that particular cycle and you can start debugging. And this is a time aware view. Like this time aware view, it turns what used to be like hours of manual backtracing into a few minutes of visual analysis. And with Xdebug, you'll not know where the problem is. You can even see when it started. So that is about the Xdebug. And next we are moving on to one of the most powerful parts of Questa OneSim's debug environment, which is the protocol debug. So this protocol debug, it actually bridges the gap between the transaction level activity and and the waveforms underneath. Or you can say like it gives you a transaction level overlay on top of your waveforms, and you can see like your decoded transaction labels like address phase or data phase or response that is annotated directly in time. And illegal sequences are highlighted immediately too in this protocol debug feature. You can even filter the transactions by value or time. And with just a click, you can highlight the items directly in the waveforms. You can just place the cursor around them and when you can focus on that particular relevant activity. And now we'll be speaking more on the Questa Sim's coverage engine. So turning on coverage, it always has cost you the simulation performance. Like larger the design was the overhead, and that has like historically pushed the teams to run coverage on a subset of tests and create blind spots at sign off. So the next gen coverage engine in Questa OneSim addresses this directly. It has this 28% faster simulation with coverage enabled compared to the previous generations. And it has 2 to 3 times faster UCDB load times for faster post-run analysis also. And the architecture generates database results that better match with your code intent with fewer false negatives and more accurate coverage and smarter defaults. So the results will be saved as a database, and that will you can see like your simulation team generates a simulation UCDB, your formal teams generates a formal UCDB, and your emulation team generates an emulation UCDB. So when you say a unified coverage, the unified coverage is like merges all the three into one sign off metric, that is as a merged UCDB, and you can use it at any point of your design, like even when you're using the Questa OneSim, or if you're using Questa One SFV, anywhere you can start using with this particular merged UCDB. So the key point here is that the coverage commands are identical regardless of what engine generated the data. And your analysis scripts, exclusion managements, and all all report of the work are the same way across your simulation and your formal and your emulation also. So now we talk about improving your simulation productivity. And we often think about faster engines. When we talk about improving the simulation productivity, we think about faster engines. But when we talk about faster engines, it's like your compilation and elaboration is where a lot of time is actually lost. And that is exactly when that is, yeah, where smart compile is designed to fix. So smart compile is like a set of time-saving compilation and optimization technologies that can cut throughout the turnaround time from the very first compile to your final simulation. So this allows like what happens here is it follows a simple divide and conquer approach. Like it breaks a single long compiler optimization into smaller parallel tasks. We can call it as smaller PDUs, and each running independently across the grid. And when only a small part of the design changes, Smart Compile reoptimizes that particular part instead of processing the entire code base. And features like timestamp incremental flow automatically detects what exactly is new. And a separate test loading lets you add or modify the test without rerunning the full elaboration. And this dynamic reconfiguration, it allows you to swap your RTL or gate level blocks on the fly at the runtime. And together, this dramatically shortens your iteration cycles. And as a result, you get a workflow which is not just faster, but even smarter. So while you're compiling in parallel and catching the results and eliminating the redundant works. So that's basically the essence of smart compile. So that is like fewer rebels, faster feedback, and higher verification throughput. So now talking about another debug feature of Questa OneSim, that would be driver tracing. So in a complex design, let's say there are multiple drivers that can contain on a single net. So driver tracing tells you exactly where and which driver is responsible for that current value on that particular net. So select, uh, basically how this works is like you select any net on the waveform window and click on show drivers. And Questa, it lists every driver which is in that particular timestamp contribution. And when you just double click on that particular waveform, when you just double click on that particular waveform edge, it like jumps directly to that particular RTL assignment, which is responsible for that transition. And this works well for both RTL simulation and your gate level netlist. So it is just as useful for your GLS as well as your RTL debug. And this feature is actually highly effective for your X propagation issues. And if you have multi-driver conflicts, like what used to be like, it could have been like a 2 hour manual trace, then that is going to become just like a 2 minutes exercise with driver tracing. And then let's say you have a failure that happens at time t, and the root cause happened before time t may possibly be much earlier. So whatever happens at time t, its root cause would have happened like way earlier. So that is where this time cone feature of Questa OneSim enables backward tracing through the simulation time to identify the exact chain of events that led to that particular failure. So this time cone, it traces the signal across multiple clock domains and hierarchy levels, and instantly revealing where, like, which is the driving source and the preceding logic with it with the precise timestamps. And here also, like double clicking on any of the edge in the time cone view, as you can see on the screen here on your right, it can navigate you to that earlier simulation event directly. And this is also like fully integrated with the visualizer, like the traced signal are automatically highlighted in your waveform window also. So you're not like searching through the noise, and you are like knowing exactly the signals that matter to you in your design. So on the same note, we have this something called as logic cone, which is the structural companion to the time cone. So where time cone is about time, like what happens before the failure. Logic cone is about the structure. It is about the logic that is connected to a signal. So in logic cone, there is something called as fan-in, which traces backwards and like to every source that is driving a net. And this answers what could have caused this value. And we have something called as fan out tracing, which traces forward and which is like everything that a signal drives downstream. And this answers like what if I what if I change this, what else is affected? So it is going to answer you that particular part. And unlike time cone, logic cone actually focuses on the structural connectivity rather than the simulation time tracing. And here also it has depth-based color coding, which shows you how close or deep each contributing element is. And this actually works alongside with time cone to give you both the structural and timing-based root cause analysis in one working environment. So, and to see more about the difference or you say relationship between the time cone and logic cone. So we have this a difference, or you can just say I've placed both the time cone and logic cone windows together here. You can see like time cone, it basically traces the signal behavior backwards through the simulation time. So it is your tool for root cause analysis across the time domain. And logic cone explores the complete structural logic path, which gives you full visibility into the combinational and sequential connectivity. And the power is in using them together, actually, as I said. And both the views are like synchronized with your waveform window and the RTL source window. So navigating in anyone is will automatically update the other. And if there are any suspicious signal found in the driver tracing, it can be immediately analyzed further with either using time cone or logic cone or even both. And together, driver tracing, time cone, and logic cone can give you a comprehensive framework for timing and structural debug, covering every angle of the root cause analysis. And next feature that we'll be talking about will be state machine debug. And this is actually genuinely impressive when you actually do it. So we know that every RTL design has FSMs like arbiters, protocol controllers, sequencers, and state machine bugs are like they're they're like notoriously hard to debug from the waveforms, like actually from the raw waveforms that you have, because you're like sometimes you're like staring at the binary coded values and trying to mentally decode like which state you're actually in. So that is where Questa OneSim automatically extracts the FSM structure and the state transitions directly from your RTL, so that there is like no manual configuration required, and it displays the active states and the transition paths, which is like which is actually there dynamically during a simulation in a live graphical diagram actually. And the invalid transactions, dead states, unreachable states, and looping behavior, they're all detected and they're also flagged automatically here in state machine debugging feature. And even the waveform activity is correlated with your state dependent control flow. So you can see exactly which state triggered the wrong downstream behavior. And it even simplifies debugging of your protocol controllers and sequencing logic and even error handling FSMs. And it also works alongside your waveform and RTL views, just like all the other previous features that we have spoken about, so that it is like in fully synchronized with your behavioral debug. Next, we will be talking about the VHDL innovations. Like Questa OneSim also introduces new VHDL innovations. Like we can see this, we can see like based on the data here that the number of projects using VHDL for verification, like using OSVVM, using UVVM is increasing. And for years, like VHDL teams also wanted the same features, like verification capability features that is like used by the system delivered users. Like for example, say randomization, functional coverage, and even like software driven verification. And now, actually, with Questa OneSim, all of those are achievable. So Questa OneSim actually brings you full VHDL 2019 language support, and you can even do parallel sim that is also extended to VHDL. And we have a new coverage engine for VHDL, and you have UCDB interoperability, and the full visualizer debug environment also is supported now for VHDL, including the X debug feature, which we have already spoken in the earlier slides, and the driver tracing, the time cone, logic cone, and even the state machine debug, which was already spoken in the previous slides. All of these are also available for the VHDL designs now. So that is more about the topics that we are actually covering for today. And now coming on to the quick overview, let's bring it all together now. So we have Questa OneSim engine, which is like the core of everything that we have talked about today. So that is it gives you the fastest RTL, fastest gate level simulation and DFT simulation engine in the industry. And that is delivering up to 5 times the user productivity, which it has more speed, more throughput for the same design complexity. And so whatever the design complexity you have, you'll get there faster. And next, we spoke about advanced debugging here. And all of these debug features are integrated well with the Questa's Visualizer GUI. And it gives you the waveforms, it gives you the data flows, it can give you the FSM viewer, it gives you the X debug, everything in one environment, and all the windows are synchronized well with each other. And so let's say you're chasing a bug, and in every view, like your waveform, the source view, the state machine view, the logic cone, and the time cone, the X debug, everything move together. So you don't have to like switch between the context, and there is no lost state found in any of the windows that are integrated together in that particular window. And then we spoke about the coverage engine, which is like 28% faster coverage collection compared to the previous generations of Questa that we had. and 2 to 3 times faster UCDB load times also it provides. And which means like you can close the coverage faster and without it becoming the bottleneck at sign off. And we spoke about unified coverage too, where you're not just like merging the numbers, you are like merging the simulation, formal, and the emulation results into one single sign off metric. And like with the same commands and the same analysis flow, regardless of the engine that is generating that particular database. And then we spoke about smart compile, where you can do incremental and parallel compilation, like which actually drastically cuts your build time between the runs. So with this, you can fix a bug and recompile only what is changed, and you can go back to simulation within minutes, and not like 45 minutes ka full blown simulation optimization and all of those things, so that and you don't have to rebuild the entire thing that you were doing otherwise. And then we spoke about the driver tracing, where you can trace any net directly to that particular RTL line which is driving it. So, like this also, what used to be hours of manual waveform navigation, like now follows a signal back to the hierarchy level through the through the hierarchy level, which is now like just like a click and a jump away. So this also it can help you to resolve the multi-driver X issues within minutes. And we even spoke about the time cone and logic cone, where you can narrow your debug scopes by tracing the signals back through time with time cone, and backwards through logic topology with the logic cone. And instead of searching through millions of signals, you're like just looking at one which would have cost you the failure, and you can just like focus and you can just focus on that particular bug, and it will be even instantly highlighted even in the waveforms also. And we even spoke about the VHDL innovations that are in the new Questa OneSim, like which is like whoever is now working on VHDL, it has the new VHDL 2019 support, it has parallel simulation, and even the new coverage constructs. Everything is here for you now. And yeah, so that is pretty much basically everything that we covered today. And it even has this, you know, equally support for the entire VHDL flow also. So this is pretty much of what we have covered today. This is Questa OneSim, which is just one tool and like entire capability connected through it seamlessly. So this is my contact details. So please reach out if you have any queries or any technical inquiries. And thank you so much for your time today. I hope I gave you a clear picture of what Questa OneSim delivers, like not just as a simulator, but as a complete debug and verification productivity platform. And we have more topics to cover in the further series of this webinar. So you guys just stay tuned for the updates on the next topics and the next webinar dates. So if you have any questions, please drop them in the chat box. We'll take it up now. So thank you once again for joining.
Hello. Yeah, am I audible? Okay, so Sukesh Kumar. So we have a question from Sukesh Kumar. He's asking how the tool will visualize the state machine from RTL. Can I have an example? So right now in this session, we cannot show you the demonstration. So tool will visualize your state machines in two ways. Okay, one in the code coverage. Okay, your actual code. It can identify which construct that you have written in your RTL can be like identified as state machine. And in that, during your simulation time, you can see whether your state has been transitions or not. That is one way of visualizing our state machine. And the tool has the capability to visualize your FSM as a graphic also. Okay, you can see a graphical view of RTL, of your state machine, and it has color schemes also. You can see which states has been executed, and even you can trace through the state machines also. You can step in, step out in the state machines also. So that's how the tool visualize the step machine in two forms actually. So any more questions from other attendees? We are like happy to answer to those questions. So Sukesh Kumar, if you are like satisfied with the answer, please type it in the chat box. If you need further clarification, you can just type also. You're welcome, Sukesh. Thank you for the question. Any more questions from our attendees side? We are happy to hear actually. Okay, so we have another question from Manas actually. Can you show its integration with Agentic toolkit? So again, thank you, Manas, for your question. So right now, in this particular session, we are not showing demonstration. I'm very unfortunate to say this, but yeah, in the future, we would love to do that. We will love to show you how to integrate Questa OneSim and other Siemens portfolio with the Agentic AI toolkit. We will keep this question in mind. Thank you, Manas. Thank you. Thank you for the question. You're welcome, Anita. Thank you. Uh, okay, so I'm assuming that our attendees don't have any more questions. So, okay, just to wrap up all this session, thank you everyone for attending this session again. And also, we would like to end by informing that in the future also we are planning more webinar sessions, more interactive. We'll make it more interactive. Actually, maybe we'll try to include the short demonstration also. So please stay tuned to our webinar pages, to our LinkedIn pages for further updates on webinars. And we will also try to send the webinar invites personally on whichever the email that in our we are having in our database. Thank you everyone. Thank you for attending our session. Thank you. We will end this session.